Okay, so last week on Wednesday we did talk about Ruby data types a bit. We're just going to go into some more detail with strings and Booleans this morning. And these are really important data types, these two data types, strings and Booleans. We use them in any programming language, and we use them in every program we write. Okay? So it's really important to understand them. And the way that they work in Ruby is more or less the way they work in other languages. Okay? There might be some little syntactical differences, some little semantic differences, but they're tiny differences. For the most part, strings and Booleans work this way in every language. So, we looked at numbers on Wednesday, and we talked about integers, which are whole numbers, no decimal points. Okay? And unless you tell Ruby otherwise, by declaring or initializing a variable with a decimal point, if you initialize a variable with a number, it's going to make it an integer. It's going to assume it's an integer. Okay? So integers are whole numbers, no decimal points, negative or positive. Decimals we're familiar with, and decimals and floats in programming are distinguished by their size. So floats can be much bigger than decimals can as far as the data types go. Don't worry too much about that at the moment, okay? In Ruby, we do, what is the method we use in Ruby to change an integer to a float? Does anybody remember?
2i.
2i changes it to an integer. 2f. 2f will change an integer to a float or a string to a float. So we can use, we can perform mathematical operations on numbers. No surprise there. Yes, Chris?
We had a question about gets and 2 and 2i to turn it into an integer or a float or whatnot.
Yes.
Is there a method for just not gets a string but an integer?
There isn't in the basic library. There may be something in another library, in a gem library. There might be something. But it's really not a huge deal. So did everybody hear the question, is there a way to get input from the user and get that input as a number rather than getting it as a string like gets does and then converting it to a number? There isn't in the standard library. So in the standard library, we just use gets, and we just convert the result to an integer or a float if we need an integer or a float. That's all right. Okay, so strings. Strings can be any value in quotes. So that's the way we tell Ruby or other languages that we have a string, is we put the thing in quotes. So we can put letters, words, numbers, symbols, spaces. It doesn't matter if it's in quotes. Then Ruby is going to interpret it as a string with the exception of interpolation, right? If we've got a hash symbol and curly braces inside of double quotes, then Ruby is going to recognize that you're telling it to interpret what's between those curly braces, right? But other than those particular symbols used in that way, you can put anything in a string and Ruby will just interpret it as part of the string. Okay? So some useful string methods we've already looked at. We've looked at 2i and 2f, right, to convert a string to a number. Whether we want an integer or a float, we can use those methods to convert a string, and those are useful for the reason we just talked about, which is because we get user input in Ruby with the standard library. We use gets, and gets always returns a string, and we may want to get numbers from the user. So we'll use 2i or 2f for this purpose quite a bit in Ruby. So you can also convert a number to a string. Does everybody know how to do that by now? Yeah, Aiden? Yep, 2s. So we can take a number and we can use 2s and turn a number into a string, which is also really useful.
A couple people don't have their meat accepted.
Oh, thank you. Let's fix that. All right. Is anybody else not in? You should be okay now, Mitchell. You should be good now. All right. Thank you. Okay, so we'll talk about arrays tomorrow. But arrays are really convenient data structures. We use them as much as we use strings. And often we'll want to convert a string to an array so that we can perform some manipulation of the data. And it's easier to do it with an array than with a string. So there are a couple of methods that let us convert strings to arrays in Ruby. One is, I say chars, other people say chars, I say chars, because character, that's what it stands for, characters. So that method, if you call it on a string, will give you an array of characters. The other one is split. So split, you have to pass an argument. By default, it might actually be an empty string. Let's have a try. I or B. So if I have a string, A, B, C, and I call split on it, it doesn't do anything. So if I call ABC dot split with an empty string, then it will split it into an array of characters. Okay, and chars will do the same thing, or chars. ABC chars will do the same thing. There are some other interesting methods on string that produce arrays that you can look up yourself. So some examples are lines, and lines will take a multi-line string, a string that has new lines in it. So this comes in handy when you're reading from a file, for example, or if you're using not the standard library, not with gets, but with another library, reading in multiple lines of user input, and you wanted to break that up into an array where each line is an element of that array, you can use lines. Scan is another one that does some searching in a string for certain patterns and then returns an array of things that match on that pattern. So those are really useful methods as well. String has lots of useful methods. And what I tend to do is, if there's something I'm trying to do with a program and I have a string that I'm dealing with, I think about what I want to do with that string, and then I might go look at the methods on string to see if there's something clever that will help me to do it. So that's a pretty popular, common thing to do as a programmer. Ooh, let's fix that. See what? There we go. So either one of those will yield an array of characters. Okay, so here's some other useful string methods, and these methods give you information about a string. So abc.length, what do you think that returns?
Number of characters.
Yes, so in this case, it'll return 3. What about include? What do you think that does?
Add something.
It returns a Boolean. It returns a true or false. When does it return true?
Does it include B?
That's right. That's right. So in Ruby we have a convention with method names that if they end with a question mark, they return a Boolean value. They return true or false. Okay? So this method will return true in this case because that string does include the character B. You can pass a whole string to include, so if you want to see if a string includes a substring, you can use it that way. Very handy. Oops. Empty. So empty will return true if the string is empty, and false if the string has any characters in it. What about start with? Have a guess what that.
The string stuff.
Yeah, exactly. So it's really nice in when methods are named in a way that makes it really clear what they do. So you should endeavor to do the same thing when you define methods. They should be really clear. And if you define a method that returns a Boolean in Ruby, you should put a question mark in the method name. So this one would return true because ABC, the string ABC starts with A. Okay, what about end with? That's right, and in this case it's going to be false, right? Because that string ends with C and not B. Okay, what about index? What do you think that returns? What do you think index does?
The number Of location.
That's right. That's right. Where we start with 0, just like with arrays. We start with 0. So in this case, it'll return a 2. Is that clear for everybody? All of those methods make sense? So these are methods that you'll probably use a lot. Here are some more useful string methods, and these are for string manipulation. So this is to get to change the string. Okay? So capitalize. What do you think that does? Yeah, that's it. Capitalize is the first letter. What about downcase? It makes all of the letters lowercase. And upcase, similarly, makes all the letters uppercase. That's right. That's right. Exactly. What about strip? Yeah, it removes all white space. Leading or trailing. Not all white space inside the string, but all leading and trailing white space. Where white space includes spaces, tabs, new lines, carriage return, line feed. All of those things are classified as white space, and strip removes all leading and trailing white space. Okay? So we use that a lot of times when we're processing input, either from a user or from a file, to pull off the extra white space at the beginning or end, or new lines or carriage returns. So that's going to return the string ABC. Chomp. Do you remember chomp? I think we talked about it Wednesday. Did we talk about chomp? No? Okay. So when we get user input with gets, gets always gets the new line, because gets waits for the user to type the enter key. And so the new line that gets generated by the enter key is always included in the string that's returned by gets. But when we get user input, we generally don't want that new line. So we use chomp. So chomp, similar to strip, but it only removes trailing new line, carriage return, line feed. Okay? Not trailing blank space, not leading anything. Trailing, new line, carriage return, and line feed. That's what chomp does. Reverse. What do you think that does? Reverses the string. And what about delete? You pass it an argument. What do you think it does? It deletes that substring from the string. So everywhere it finds that substring, if we had multiple A's in it, like I do in this last example, it will remove all of the A's. So wherever it can match that pattern that you pass to it, it deletes that pattern from the string. Okay? Now, all of these methods return the value that you see on the slide, but they don't alter the string itself. Okay? There are versions of these methods that do alter the string itself, and those have an exclamation point at the end of them. So, for example, I'll show you an IRB. If I have, let's say I have a string, let's call it name. Can everybody see my terminal? Okay? Is it too tiny? Should I make it bigger? I'll just make it, oh, it's not letting me do that in IRB. Okay, so if I have a variable called name, and I put my name there, okay, and then I say name dot capitalize, and it's the US spelling of these words. Okay, in programming, it's always the US spelling. So if it has an S in it instead of a Z or a Z, it's going to have a Z in it. Okay, it's the US spelling. So see how it capitalized that string? But if I have a look at name, it's not capitalized. Okay? So it returns the string capitalized. That's the value it returns. So I could say, for example, cap name equals name dot capitalize. Okay? Now cap name, what do you think it has in it? Do you think it's capitalized? It is, but name is not. Is that clear for everybody? However, if I say name dot capitalize, you have to spell it right though, with an exclamation point, it actually alters name. Okay? That's called a destructive method. It's destructive because it alters the variable on which you call it. It alters the data stored for that variable. Okay? So all of the methods on this slide have an exclamation point version that alters the variable itself.
Does it stay that way?
It stays that way. That's right. So it depends on your use case. If you want the variable to be changed, what it's storing to be changed after you call this method, then call the one with the exclamation point. If you want to retain what's in the variable, but you want to mutate the string somehow, modify the string with one of these methods, you can store that in another variable and use that modified version. Okay? Very handy. So, for example, if I am comparing some value that may or may not be capitalized by the user, right? So say I give the user, if you think about the banking app, if anybody's tried the banking app yet, and the user says they want to deposit, and they might type it in with a capital D or a little d, or they might capitalize all the letters, or they might do some random capitalization. I want that string to match on the word deposit no matter how they type it. Okay? So I might compare it to all lowercase deposit and downcase the string that they give me. But I may not want to alter that string. I may want to keep that string that they gave me exactly as it is, because maybe I want to display it back to them the way that they typed it in, or for some other reason. Okay? So if I want to get the downcase version for comparison, then that's one way that I might use those methods without using the exclamation point. Okay? These methods are super handy. So let me just... Okay, so any questions about strings before we move on? You're going to get so much practice with strings. You'll use strings in most of the morning challenges. And in most of the all the programs you write, you'll use strings. You can't get away from it. Okay, so you'll get lots and lots of practice. I encourage you to check out the Ruby docs to see what other string methods are available and have a play with those when you're doing morning challenges and afternoon challenges, to see which ones you might find interesting and useful. So let's talk about Booleans. Booleans are named after George Boole. That's his picture. So Booleans have one of two values, true or false. And Boolean algebra or Boolean logic is concerned with combining Boolean values. That's what it's about. And we use Boolean logic to control the flow of an algorithm or program. In fact, all of computing and programming is based on this data type. It's all zeros and ones, y'all. All of it. It's all zeros and ones. When you study computing at the level of circuitry, it's all zeros and ones. It's power, no power. That's all it is. It's all reduced to that. It's amazing, when you think about that. Everything that a computer can do, everything that a program can do, can be reduced to zeros and ones. So, fun exercise, take a simple program, write it in assembly language, translate it to machine language, and then to binary, and you can actually see it in zeros and ones. You can take any program that you write and reduce it down to zeros and ones. Okay? It's really fascinating. So until quantum computing becomes a regular thing, then all of our computing is based on this binary system. So quantum computing opens it up so that we have more than two states. And there are experimental quantum computing systems. Yes, Chris?
Is it more than two, or is it three?
No, it's two.
Sorry, for quantum.
Oh, for quantum, I think it's 6. Yeah. Yeah. So that changes things radically, as you can imagine.
It's not like on and off and on and off.
No, it's this sort of continuum.
Somewhat disagree and somewhat disagree.
It's this continuum of states related to the spin of quarks. So And it's also possible that something can have more than one state simultaneously. So it completely changes the way we think about computing and programming. We have to write all new languages to deal with that, and all new programs and all new applications. It'll be a fun time. There'll be lots of jobs. Yeah. But today, everything that is out there in the world that's used by people is based on this binary system.
And do you
Yes.
see it like, or just because generally speaking we have little knowledge in comparison, do you see it being similar in the languages that you're learning, or is it going to be like in regards to syntax?
Yeah, I think at the level that we write programming languages, there will definitely be similarities. The big differences are going to be in the way at the machine level and the assembly language level. That's where the real differences are going to be. But it's going to, the ways it'll be different at the programming language level is that there's going to be so much more that's possible in the way that you solve a problem. The way you approach problem solving will be so different that will dictate changes in the way we use programming languages and the way that they're written. Yeah.
So it's just like new methods, new ways of doing things.
Yes, completely new approaches to problem solving. So that's the base of it, is we'll have completely new approaches to problem solving. And of course, everything about the way we write programs and the way that languages are created is based on the way we approach problem solving. So
Booleans would change massively. Because you'd have, instead of having yes or no, you'd have 6 different options to choose from, sort of thing.
yes, that's right. That's right. Come in. Okay, who's done truth tables before? Has anybody done truth tables? No? What about in genetics when you do the is it Punnett squares? I'm trying to remember what it's called. Okay, that's all right. So we're going to look at, today we're just going to look at and, or, and not. Because everything is based on and, or, and not. Okay? So we use these conditional operators and, or, and not to combine Boolean values. So the idea is that we've got two Boolean values, a true and a true, or a true and a false, or a false and a false. And we'll combine those using Boolean operators like and, or, and we will have some result. So in the case of and, if we have two Boolean values and we use the and operator between them, it will evaluate to true only when both values are true. Okay? So this and this must be true in order for the result to be true. If one of them are false or both of them are false, then the result of a Boolean and operation is false. Okay? So I could say, if it's raining and it's cold, I'm not going anywhere tonight. Now, if it's not raining, but it's still cold, I'll still go somewhere. Or if it's raining but it's not cold, I'll still go somewhere. If it's raining and it's cold, I'm not going anywhere. Okay? If it's not raining and it's not cold, if it's nice and warm and pleasant, I'll go somewhere. So, it's just a convention when you see truth tables that they use P and Q. So that's why I used P and Q, because it's likely that you might see that somewhere else. So if P and Q are both true, then the result is true. In every other case, P and Q is false. Okay? Or, for the or Boolean operator, only one of the values has to be true. Okay? Only one of the values has to be true for the result to be true. So if P is true or if Q is true, the answer is true. They can both be true, that's fine. One of them can be false, that's fine. If they're both false, though, the answer is false. So true and true is true, true and false is true, false and true is true, but false, I said and, I meant or. P or true is true, true or false is true, false or true is true, but false or false is false. So the way that I remember it is that for and, both values have to be true. And for or, as long as either value is true, then it's true. Not evaluates to the opposite of the input. So when we consider the not truth table, we just consider one value. And the not will be the opposite of whatever it is. So if P is true, we did need 4 items here. If P is true, then not P is false. And if P is false, then not P is true. I'll fix that up. All right, so that's it about data types, or the basic data types that we're going to talk about today. Of course, we use Booleans in conditional statements, right? That's why they're so important to us. So that's why it's important to understand the way that and operates and the way that or operates and the way that not operates, because we'll use these conditional statements a lot of times combining 2 conditions in a conditional statement, and we have to understand how that's going to operate. So we'll get lots of practice. There are some resources. The first ones there are just from the Ruby docs. So that was just the Ruby docs for the methods on those types. And that last one is a really nice, pretty simple description of Boolean algebra or Boolean logic. So if you feel like you need a better understanding of that, you can have a look. We will cover Boolean algebra again when we do discrete maths. So we'll cover it in some more detail then, and we'll talk about some different kinds of operators like exclusive or. Okay, any questions about data types? Let's talk about conditionals. I'll send you the link to this one.